Alright guys, welcome back. We're going to be solving another question from the chapter 3 of Meriam textbook, question 22. And in this question, we need to determine the magnitude of force P that is required to release the pawl OB counterclockwise from its locked position. We know the torsional spring constant is 3.4 Newton meter per radian, and the pawl end of the spring has been deflected 25 degrees counterclockwise from the neutral position in configuration as shown, and we can neglect any forces at the contact point B. So what's happening in here is that we have a moment at the spring where we can call it ms, which would be basically the constant that we have, which is 3.4 Newton meter over radian. So we have a moment unit in here, and we have the torsion of the spring in radian, and we know that deflection in the spring is 25 degrees. So as long as we have that 25 degrees in spring, we can find the moment. So we have the force P, which we can dissolve it in these two components. So this one, we know this angle here is 10 degrees. So this one will be P cosine of 10 degrees, and the other one will be P sine of 10 degrees. So here we have to find the deflection basically in radian in order to find the moment of the spring. So since we are in equilibrium, we're going to go with the moment about 0.0 counterclockwise positive. And if we look at this, we'll see that we have to have this ms. Since the deflection is counterclockwise, the moment in the spring will turn that bar clockwise. So we have a negative moment of ms plus moment of ms, which will be what we have in here. So minus 3.4 times the deflection, which is 25 degrees. And if we want to find that based on radian, we need a conversion for degree to radian, and we know 180 degrees is equal to pi. That way we can get the moment in radian. So that's pretty much the moment of ms. So this whole part is the ms, which we have a negative sign since it has to be clockwise. And we have the moment of the P cosine of alpha, cosine of 10, which as we can see is a counterclockwise moment. So plus P times cosine of 10 degrees, and distance that we have is what we have from here to here, or 30 millimeter, or 30 divided by 1000 in order to get it in meter. That's about it for the cosine. And for the P sine of 10 degrees, we basically have, so this will be the line of action. We have this distance, or the 20 millimeter divided by 1000 is equal to 0. And basically, if we factor a P in here, we have 0.03 cosine of 10 plus 0.02 sine of 10 is equal to our ms. So we can calculate our P from here, which is going to be 44.92 newtons, and the final answer for this question. So yeah, no need to freak out about this spring that we have in this question. Usually for the spring we have the force is equal to constant times the x, or the displacement of the spring. But this is a different spring that we know our constant has a different unit, and based on the deflection of the spring, we can find the moment in this type of the spring. So that's probably the only new thing in this question. The rest is pretty similar to what we covered in the channel. And so yeah, let me know if you guys have any questions. Please make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.